So, Assalamualaikum warahmatullahi wabarakatuh. Kabur je kamera ni. Internet kot. Internet slow sikit. Can you guys see? Sekejap Saya buka bagi besar sikit. Bagi slide dah besar. Muka kecil balik. Better lah. So, testing. Mic okay? Mic okay? Muka okay tak? Semua benda okay ke? Ada benda yang tak okay? Malam-malam ngantuk lah. Okay je. Alright. Okay, so let us start so that if we start early, we can actually finish them a little bit early. Taklah early sangat tapi macam boleh lah. Okay, so this is a new topic or a new chapter which is the chapter 3. So this is numerical method. So basically we're gonna learn numerical method. It's gonna take us around 2 hours. So last time I thought that we should be able to finish those within a day, but never mind. So let us do it, and then let us take another hour on Tuesday, and then on Thursday we gonna learn a new chapter, which is chapter 4, conics. Okay, so numerical method. Basically, what we are going to learn today is the thing on the left hand side. So we are going to learn 3.1 as well as 3.2. So basically, we're gonna learn how to find the solution of a non-linear equation, where basically we're gonna use the Newton method to approximate the solution for a non-linear equation. And then for the lecture or the next lecture, we're gonna approximate the definite integral, where we're going to use trapezoidal rule in order to approximate the solution for the definite integral. Okay, so let us continue. So at the lesson, you should be able to, firstly, the first 15 minutes of this lecture, you should be able to look approximately a root of an equation by means of graphical consideration and or searching for a change. Okay, so now let us see what do we mean by a graphical consideration or a sign change. Okay, so try to solve the following. Okay, so linear equation, if let's say we have x minus 9 equal to x plus 3. So how to basically you're going to collect all x to the left hand side, all the numbers go to the right hand side. So we are going to get 2x minus x, which is 2x is definitely equal to 4. So this is a linear equation where we simply have x to the power of 1 for each of them. For the second one, we have x squared minus 4x minus 5 equal to 0. So this is not a linear equation, but this is actually a quadratic function. So how do you solve a quadratic function? And then x cubed minus 8 equal to 0. So this is actually a cubic function. Okay, so how do you solve a cubic function? And then if let's say we have x cubed minus ex equal to 0, how can we get the value of x? Okay, so let me give you around 20 seconds for you to try to use your calculator. Can you tell me what is the value of x for x squared minus 4x minus 5 equal to 0? If you try to solve them, what will be the value of x? X squared minus 4x minus 5 equal to 0. Okay, so now let us try to see the solution. Okay, the solution for the first one, the B. x squared minus 4x minus 5. So we can actually factorize them to become x minus 5, x plus 1 equal to 0. So you will get two values of x, which is x equal to negative 1 or x equal to 5. For x cubed minus 8 equal to 0, so we're going to bring negative 8 to the right hand side, so it will become positive 8. So we are going to get x cubed equal to 8, and then 8 is actually 2 cubed, so we have a similar power or the similar exponent over there. So we can actually compare the base. So we should be able to see that the x is actually equal to 2. So basically for B and C, we can actually solve to get the value of x. So now we might try to ask ourselves, what about if we have cube minus ex equal to 0? Can we get what is the value of x? Boleh cari tak macam mana nak cari nilai x? Okay, so basically, none of the method for solving the equation apart from drawing a graph would enable us to solve the equation x cubed minus ex equal to 0. So as you can see, the method that we use when solving a linear function, the non-linear function for quadratic, cubic, we cannot use them in order to find out what is the value of x for x cubed minus ex equal to 0. Kita tak boleh nak jadikan x sebagai subject. So that is what we mean by we cannot solve them. We cannot making x as the subject. Okay, so none of the method will enable us to solve. So we cannot find out what is x. It is impossible, definitely impossible to find an exact solution, but we can find an approximate solution. Okay, so what is the difference between exact and approximate? So exact solution, that means exactly. That is exactly the solution for us. So x is equal to something, that is exactly the solution. But when we are saying approximate, then it might be correct up to 3 decimal places. So mungkin dalam 3 decimal places, it will be correct. But when it comes to 4, it might correct, it might not correct, because we simply approximate them. Kita hanya menghampiri sajalah. We approximate them. Okay, next. The most commonly used method have two main parts. So the first one, we want to find an initial approximate value. So this is basically what we are going to learn for the first part of the lecture, where we're gonna find an approximate value by either using the graphical method, or we can use the algebraic method, or we can actually find the sign change. And then the second part is improving this value by iterative process. So that is actually the second part of this lecture, where we are going to learn how to do the Newton-Raphson method. So the Newton-Raphson method is also known as one of the iterative process. We have quite a lot of iterative process, but this is actually one of the simplest one for you guys. Newton-Raphson method. It actually comes from two person. Newton is that Uncle Newton, Raphson is those Uncle Raphson. So they do uncle. Okay, so how to find the first approximation to the zero of a function? So how to find them? Suppose that f is a continuous function at every point on the closed intervals starting from A up until B. So it's supposed to be a continuous function. So tak boleh ada break kat tengah-tengah. And then if, let's say, fx is greater than 0, or you can say that fa is a positive value and fb is less than 0, so fb is a negative value. So this is one part now. Fa is positive, fb is negative, or fa is negative and fb is positive. Then f has at least 1 0 between x equal to a and x equal to b. So based on the graph, you can actually see them something like this. So a is on the left hand side. So if you substitute the value of a for your function, the value over here, the value of our y is actually greater than 0. So this is a positive value. And then substitute at b, you're going to see that the value for fb is less than 0 So that is actually a negative value. So satu nilai y dia positif, satu lagi nilai y dia negatif. So obviously if one of them is positive, another one is negative, there must be somewhere in between A until B where the value of the y is actually equal to 0. So that is our aim. We want to find out what is the value of x such that the y is 0. Okay, so the other one, we might have FA such that it will be a negative value. And then if we substitute the value of B, it's supposed to be a positive value. So one of them is negative, one of them is positive. So if we have a continuous function, definitely we have a point where the value of the y is supposed to be something that is equal to 0. So satu positif, satu negatif. So function dia macam tu. Kita mesti kena ada satu nilai yang mana y dia sama dengan kosong. So those are the value of x that we want to find actually. Okay, so initial values. Okay, so the initial value of the root of f equal to 0 can be located approximately by either, so the first method, so we can actually use a graphical method or we can use algebraic method. So you can use graphical method where you sketch the graph, or another one is by using the algebraic method. Okay, so let us see the graphical method. What do we mean by the graphical method? So if let's say you only have one function and the function is very easy for you to plot them or sketch them. Okay, so if let's say you only have one function y equal to fx, then you simply plot or sketch your graph. So the real roots are the point where the curve cuts the x. Okay, so this is the graph. So this is the roots. So that is the value of x naught. So where the curve cuts the x is this. Okay, so if say the function is we learn how to sketch them directly for maybe something like sin x minus cos x. So we haven't learned how to actually sketching both sine and cos at the same time, but we do know how to sketch for sine and we do know how to sketch for a cos. So what we should do is that we should separate them into two. Okay, so if let's say we have sin x minus cos x equal to 0, so that means sin x is equal to cos of x. So you're gonna sketch the graph for sin x, and perhaps this one is your cap f, and then cos x, you're gonna let them gx. So you sketch both of the graph. So sketch fx first, and then sketch gx. Once you sketch both graph, then the real roots are actually where this graph intersect. So bila kita lukis graph tu, kita tengok dia intersect dekat point mana. So those are actually the value of x, or the solution, the approximate solution for that function. Okay, so let us go to the first example. Find the approximate value of the equation ln x plus x minus 4 equal to 0 by using the graphical method. Okay, so obviously, we only learn how to sketch ln x. That means if you go back to your first semester, we never learn how to sketch ln x plus x. Dia kalau ln x, dia ln x je. Tambah constant tu okay lagi. Tapi ln x plus x, we never learn them before. So we're going to separate this into two. So it will become ln x equal to 4 minus x. So I'm going to sketch the ln x first. And then I'm going to sketch 4 minus x. So this is like cap f, that is like gx. And then we're going to find out where does the point, or where does the graph intersect. Okay, so now let's see the sketching part. Okay, so that is the graph for ln x. So 4 minus x, that is actually a linear graph. Y equal to 4 minus x. So basically, if you sketch them very, very carefully, you should be able to see or you should be able to approximate your value of x. Okay, so based on this graph, where does the graph intersect? So the graph basically intersect over here, right? And where is that point? The point is somewhere in between 2 and 3. So what I will say is that the root is in between x equal to 2 and x equal to 3. So my initial approximation for this value is perhaps around 2.5. So this is my initial approximation. Baru initial lah. Maksudnya based on graph, teka-teka lah agak-agak rasa macam 2.5 kot. Okay, so basically after this, we're gonna learn how to improve this. So this is simply an initial approximation. We can actually improve them by using an iterative process. Okay, so this is by using the graphical method. So you're basically gonna sketch the graph, and then based on where does those two graphs intersect, we're gonna see, or we're gonna approximate what is our initial value. So those are the graphical method. Okay, the second one, the algebraic method. Okay, so what is algebraic method? Algebraic method, we are searching for a sign change. That means we want to get two values of x such that when we substitute the first value of x, we're gonna get something like positive or negative, another one, another positive or negative. So it must be different. So if one of them is positive, another one should be negative. If the first one is negative, the second one should be positive. So we should have a different sign. Baru kita nampak macam kita ada jarak sini kan. Jarak sini, baru kita boleh ada yang tengah-tengah tu lah. Sorry, ada message sekejap. Okay, so now let's see. Find two values of A and B such that FA and FB have different sign. So either FA is perhaps something like FA greater than 0, FB less than 0, or we are looking for something such that FA is less than 0 and then it will give FB greater than 0. So sign change, different sign. So if we have a different sign between A and B, what can we say is that there must be at least one root in between A and B if the function is continuous. So that is basically what we have learned so far. Okay, next. Right, so show that the equation ln x plus x minus 4 equal to 0 has a root between x equal to 2 and x equal to 3. Approximate the root correct to one decimal place. Okay, so ln x plus x minus 4 equal to 0. So this is the most important thing. Do make sure that the right hand side is equal to 0 first before you can write down what is your fx. So do make sure the right hand side is 0. So that means we can write down our fx. Fx is equal to ln x plus x minus 4. If let's say you do have something on the right hand side, bring it to the left. So do make sure sebelah kanan tu mesti kena kosong sahaja. Okay, so after you make sure that the right hand side is already 0, then the function on the left hand side, that is actually our fx. So we want to show that we actually have a root between 2 and 3. So try to substitute with x equal to 2 and substitute with x equal to 3. Okay, so fx is equal to ln x plus x minus 4. So substitute with f of 2. So we got ln of 2 plus 2 minus 4. So now use your calculator and find out what is the value if we have ln 2 plus 2 minus 4. What is that value? Is it a positive value or is it a negative value? So those are the things that we want to know. Okay, so I'll do that a little bit fast. So the value of them is negative 1.307, and we do know that this is actually less than 0. So this is what you need. So the sign is negative, so this is less than 0. So try to substitute with x equal to 3. substitute with x equal to 3. So we got ln 3 is equal to f3 is equal to ln 3 plus 3 minus 4. So again, try to use your calculator. What is the value of ln 3 plus 3 minus 4? What is that value? Is it a positive value or is it a negative value? So obviously the question asked to show, right? So if the question asked to show, then there must be a different sign between them. So one of them is already a negative value, another one is supposed to be something that is positive. So this is the positive of 0.086, and this is actually greater than 0. So that number is greater than 0. And as you can see, one of them is negative, another one is positive. So we do have a different sign. So you must write down the conclusion for them. What do we mean? If we have one positive, one negative, what do we mean? Is the root is definitely between x equal to 2 and x equal to 3. Or you can write them down as this. So this is your conclusion. Different sign. Hence, there. Lajunya dia. Sekejap. Ni. Okay. There is a root between x equal to 2 and x equal to 3. So nak tulis yang macam ni pun boleh. The root is in between x equal to 2 and x equal to 3, or normally for me, I prefer to make those curly bracket and then write down different sign. Hence, there is a root between x equal to 2 and x equal to 3. Okay, so the second step, you got to approximate the root. So how to approximate the root? So we basically take the first digit plus with the second digit, and then we divide them by 2. The first number plus with the second number, and then we divide them by 2. So our initial approximation is 2.5. So correct to 1 decimal places. So that is the reason why we only have 1 decimal places over there. 2.5. Okay, done with that. Next. Okay, so now let us see how to use them to approximate the solution by using an iterative process, where in your syllabus we're going to learn how to find the root by using the Newton-Raphson method. So before this we already have the initial approximation. So now kita nak murnikan dia lagi. Murni ni bahasa Inggeris apa lah? Bukan extend the idea. Macam mana? Nak memurnikan lagi root dia tu. I don't have the word in English. Tak apalah, apa-apa je lah. To find the root by using a Newton-Raphson method. Okay, next. Right, so what is a Newton-Raphson method? Okay, so imagine if let's say that is your curve, and then we are starting with the initial value where we have x naught. So x1 is the approximation to the exact root x naught. So that is our x1. Of course, the value of the y is fx1. So you can actually draw a tangent to the curve at x1, and they will meet at x2. And then at x2, you're going to extend them a little bit to find out the value of the y. So that is fx2, and then draw another tangent at x2. So draw another tangent at x2. So those will be another approximation where we have x3. And then keep on writing down and draw the tangent until you reach the x0. Biasanya kita akan start dengan x1 sebab kita nak cari x0. Normally when we sketch them, we don't really know what is the value of x0, because our graph basically is not really that perfect kan, sebab kita hanya sketching saja. So that is why The reason why we are starting with our initial approximation x1. So x1 is our initial approximation yang tadi tu, either by using the graphical method or algebraic method. Okay, so we can actually obtain the equation of the tangent. So if you use the formula to calculate the equation of the tangent, so that is basically the formula. And then you can go on. Okay, so the most important thing. Right, so this is basically the formula that we are going to use for a Newton-Raphson method. Xn plus 1 is equal to xn minus fxn over f prime xn. Okay, so what does it mean is that once we have our initial approximation x1, we can actually get the second approximation by using this formula where we have x1 minus fx1 over f prime x1. And then from this x2, we can actually get the third approximation. So this is x2 f prime x2. And of course, you can actually continue until xn plus 1. Where to stop? Until when should we stop? Normally, you can actually look at your question. Normally, the question will give you some stopping criteria. Perhaps after correct to 3 decimal places, once we keep repeating the same number twice, we're going to stop them. So basically, the question going to say how many decimal places should we stop. So, kena baca soalan betul-betul lah untuk kita tahu stopping criteria kita. Okay. Right, so basically, how to do a Newton-Raphson method. So the first step, you need to show that your function is having a root. So you can either do them by using the graphical method, or you can use the algebraic method or the change of sign. Sebab kadang-kadang saya tulis algebraic, mesti tak faham kan. So kita tulis change of sign lah. 1 plus 1 minus. So you can either use a graphical method or change of sign. So normally for me, I would advise you to use the change of sign unless question stated that you must use a graphical method. So sebab biasanya graphical ni dia leceh sikit sebab bila sketching kan, so dia depends tangan tu Parkinson ke tak masa lukis tu. Kadang-kadang dia sengit lebih sikit. Okay, so those are the first step. You need to show that your function has a root. Once you show that your function has a root, what do you need to do is that you need to find out what is the initial value. So tadi kalau dah ada change of sign, so kita carilah initial value kita apa. Okay, so what is fx? So function tu kita tengoklah function apa. So do make sure to determine your function correctly, and then you must differentiate them as well. So make sure you have your function together with its derivative. Third step, find out what is the initial value. We're going to substitute into the formula, and then we're going to write down the conclusion. So yang biasanya yang ramai yang terlupa lah. So bila terlupa yang ni, kita akan penalize sikit markah lah sebab kita tak buat conclusion. So do make sure, always make sure you write down the conclusion for whatever that you are calculating. Sebab nanti penat je kira last-last tak ada conclusion. Okay, so let me go to the first example. Okay, show that the x cubed plus x minus 6 equal to 0 has a root between x equal to 1 and x equal to 2. By using the Newton-Raphson method with the starting point of 1.6, determine an approximation to this root, giving your answer correct to 3 significant figures. Okay, so basically there are a few things that we should take note. Okay, so the first one, we have the first part where we should show that the function has a root between 1 and 2. So you need to substitute 1 and 2 into the function, show that you actually have a different sign when you substitute 1, and when you substitute 2, you have a different sign. Then you can draw to a conclusion where there must be a root between 1 and 2. So that is basically the first part of the question. The second part, they want you to use a Newton-Raphson method with the starting point 1.6. So I'm sure after you already know that the root is in between 1 and 2. So some of you might write down x1 equal to 1.5. So ada setengah tu dia nak tambah dua-dua kan. Tak boleh lah. Sebab this Newton-Raphson, they actually tell you that the value of x1 should be equal to 1.6. So dia dah ada initial value, kita kena start dengan initial value yang dia bagi. Okay, so now let's start the solution or the working. Okay, so what fx? So on the right hand side, that is already equal to 0. So I can easily write down my fx. Fx is equal to x cubed plus x minus 6. And then try to substitute x with 1. So we got 1 plus 1, which is 2. 2 minus 6. So this is actually equal to negative 4. So negative 4, that is actually less than 0. Another one, substitute with x equal to 2. So we got 2 cubed plus 2 minus 6. So 8 tambah 2, 10. 10 tolak 6. So the answer is 4. 4 is actually greater than 0. So do make sure to write down the conclusion. So jangan kira-kira tak ada conclusion. Do make sure to write down the conclusion. So one of them is positive, another one is negative. Hence, opposite sign. Then there is a root between x equal to 1 and x equal to 2. So that is basically our conclusion. Once we already test for x equal to 1, x equal to 2. So that is our conclusion. Okay, so now we're going to start with the Newton-Raphson method. So do make sure, since we already have our fx, we need to know what is our f prime of x. So kita dah ada fx, kita nak differentiate dia pula lah untuk cari dia punya derivative. Okay, so differentiate fx. So fx is equal to x cubed plus x minus 6. So if we do differentiate them, instead of x cubed, it will become 3x squared. So bring down the power, minus 1 to the power. Differentiating x, it will become positive 1. So I have f prime of x is equal to 3x squared plus 1. Okay, so now we already have our fx, we have our f prime. So what is our initial approximation? The initial approximation is given in the question. So the x1 is equal to 1.6. So let me write down the function. X is equal to x cubed plus x minus 6. And f prime of x is equal to 3x squared plus 1. Okay, so the third step, we have the initial approximation. Then the fourth step, we can start with the formula. Okay, so what is x2? x2 is x1 minus fx1 over f prime of x1. So let me write down the formula for you. So x2 is equal to x1 minus fx1 over f prime x1. So every time you see the x in f, you should replace all the x with x1. Or over here we have 1.6. So replace all the x with 1.6 and then f prime 1.6. That means every time we see the x in f prime, we should replace them with 1.6 as well. So it will become 1.6 minus 1.6 with a cube plus 1.6 minus 6 over 3, 1.6 square plus 1. Okay, so now try to use your calculator and find out what is this value. Okay, so I'll give you around 30 seconds for you to try to use your calculator. Okay, so later on I'm going to teach you how you can use your calculator much more efficient. Cik, wah sekali je. Efficient. Have you got the answer? Okay, so try to use your calculator. So the answer for this is 1.6350. Okay, so you might ask yourself, up until how many decimal places should we use? So kadang-kadang kita mungkin tertanya lah, banyak kan kalau kita guna calculator, we might have up 6 or 7 decimal places. So how to stop or when to stop? Well done, dah kira. Okay. So mungkin kita tertanya-tanya macam mana kita nak tahu kita nak stop. Okay, go back to the question. The question asks for 3 significant figures. Okay, so 3 significant figures for me, I will say to be safe, better for us to have around 4 decimal places. Significant figures beza dengan decimal places, tapi kalau dalam decimal places normally I prefer to make it a little bit safe. So if I want around 3 significant figures, I'll try to have around 4 decimal places. So my final answer, it will be 3 significant figures, but for my working it should be more than that. So yang ini okey lah, lebih daripada 3 significant figures kan, 1.63. So ini dah 4, 5 significant figures. Okay, so sekarang ni kita continue lagi. For the third one, x3. So we're gonna substitute with 1.6350. So go back to the formula, the function, substitute with 1.6350. What is your answer? Okay, so let's see. I'll give you around 1 minute for you to try to use your calculator and find out the answer. Sampai 9.39. Okay, let us continue everyone. Okay, so what is the next answer for the third? Okay, so we have 1.6344. Okay, continue. 1.6344 minus f, 1.6344 over f prime, 1.6344. Dia kena pakai bilangan decimal places yang sama. So I use 4 decimal places. So that is the reason why over here I have 4 decimal places as well. So do make sure to be consistent. So for Newton-Raphson method, please be very consistent with how many decimal places you are using. So kalau dari awal pakai 4, 4 lah. Jangan campur-campur lah. Campur-campur tu nanti biasa dia ada problem sikit. Okay, so now try to substitute with 1.6344. Then let's see what else do you have. Sama je. Memang kena sama. Sama. Okay, so bila sama, yang kita akan buat, kita akan stop. So similar with x3, right? So x3 is 1.344. x4 is also 1.6344. So x3 1.6344. x4 is also 1.6344. Then stop. So how to stop? Kalau dah dapat dua benda yang sama, stop. Okay, so now what we can do is that we can write down our conclusion for this. Then x equal to 1.63 to 3 significant figures. Okay. So again, I remind you, do make sure to find your initial value. Read from the question. If the question didn't give you any initial value, then do try to approximate any initial value and then substitute into the formula. How many decimal places? So do make sure to read the question very carefully. How many decimal places do you need? Be consistent with the decimal places. And then how to stop? Once you get two similar value, then you stop. So kalau tadi kita daripada 4 decimal places, kalau dah sama-sama, kita stop dah lah. And then do make sure to write down the final solution or what is the root. So pastikan kena jawab soalan tu lah, buat conclusion dekat ujung tu. So this is actually the conclusion. Okay, so now I'm going to teach you how to use your calculator much more quickly. So macam mana kita nak guna calculator kita cepat sikit. Kita nak kira bagi cepat kan. Okay, so dah ready lah. Clear mode lah. Make sure to clear the mode. Okay. Sekejap. Okay, erase. Okay, so what do you need is the initial value, x1. x1 equal to 1.6. Okay, dah ada initial value kan? Alah, saya dah terpadam lah pula function dia apa. Fx is equal to x cube plus x minus 6. Prime is equal to 3x square plus 1. Okay. Right, so once you have your, tiba-tiba je ada ni. Thank you. Okay, so dah ada initial condition kan? Okay, guna calculator. Masukkan nilai 1.6. Lepas tu tekan sama dengan. Tadi dah clear semua kan? Okay, tekan 1.6 sama dengan. Okay, dah tekan sama dengan. Jangan lari pergi mana-mana. Tekan answer. Answer minus. Kita akan guna double bracket. Kita buka bracket. So, satu bracket yang besar untuk fraction tu. Bracket yang kedua ni adalah untuk bahagian numerator kita. Okay, so kita tengoklah function kita apa. So, function kita adalah answer plus answer minus 6. Lepas tu kita tutup kurungan. Lepas boleh nak letak simbol yang tu pun boleh. Atau letak simbol yang bahagi tu pun boleh jugalah. Mana-mana pun tak apa. Okay, so simbol fraction ke, simbol bahagi ke. Lepas tu kita buka satu lagi kurungan. Kita letak 3 answer square plus 1. Tutup kurungan untuk bahagian denominator. Tutup kurungan untuk fraction. Lepas tu tekan sama dengan. Okay, so masa kita tekan sama dengan yang pertama, itu adalah solution untuk x2. Lepas tu, jangan kacau apa-apa, tekan je sama dengan lagi sekali. So, itu adalah jawapan untuk x3. Lepas tu, tekan je sama dengan, dia akan keluar untuk x4. So, ini adalah yang kat kiri, yang kiranya macam rough paper lah sebab kita nak tahu kita nak stop sampai berapa kan. So, working yang tadi tu yang panjang. Tapi bila kita tekan guna calculator, kita nak cepat sikit, kita nak tahu sampai berapa kan kita nak stop. Nanti takut salah tekan ke apa ke. So, biasanya kita boleh tahu dari sini lah. Kalau nampak macam alternate positif negatif, positif, negatif tu kena check balik function. Mungkin masa kita ganti nilai, function tu salah. So kena hati-hati sikit lah. Sebab tu kalau ikut kalkulator yang kelabu tu lebih senang nak guna. Sebab kalkulator tu kita nampak dia nampak layer dia sampai atas sampai bawah. So kalau yang macam ni biasanya memang kena hati-hati lah. Kalau kalkulator yang warna apa tu, warna hitam warna hitam biasa tu kena hati-hati sikit lah. Pastikan letak double bracket macam ni. Kalau kata guna kalkulator yang silver tu boleh tulis dengan cantiknya lah function tu. Okay, so kita tekan sama dengan sebab kita nak cepat sikit lah tahu nombor. Tapi dalam working masih kena tulis xn plus 1 equal to xn minus fxn over f prime xn tu. Masih perlu tulis lagi. Okay, so now let us go to the next question. So example 4. Show that the equation 2 sine x minus x equal to 0 has a root between x equal to 1. So now what is the mode? The mode is radian. X equal to 2, the mode is radian. Okay, so basically if let's say you do come up with a trigonometric function in question in chapter, which chapter is this? Chapter 3. Everything must be in radian. So mode tu boleh tukar, siap-siap lah pergi radian, pergi rad tu. Okay, so the first part we got to show we have a root between x equal to 1 and x equal to 2. So you need to obtain your fx and then try to substitute with x equal to 1, substitute with x equal to 2. Do make sure you have a different sign between x equal to 1 and x equal to 2. Once you have a different sign, we can say that we have a root between x equal to 1 and x equal to 2. And then once you already calculate the first part, the second part, find the root of equation by using Newton-Raphson method, giving your answer correct to 2 decimal places. Okay, so now let us do the first part. What is your fx? So on the right hand side of my equation is already equal to 0. So that means everything on the left is always our fx. So fx is 2 sine x minus x. Substitute with x equal to 1. Again, do remember to use the radian as your mode. So we have 2 sine 1 minus 1 equal to 0.68. F2 is 2 sine 2 minus 2, which is negative 0.18. So one of them is greater than 0, one of them is less than 0. So what we can say is that there is an opposite sign between 1 and 2. Therefore, there is definitely a root between x equal to 1 and x equal to 2. Okay, so done with the first step, let us move on with the second step. So in the second step, to calculate what is the derivative of fx, so fx is 2 sine x minus x. So differentiating sign, we are going to get positive cos. Differentiating x, we are going to get 1. So it will become 2 cos x minus 1. So fx is 2 sine x minus x. F prime is 2 cos x minus 1. Okay, so now we're going to find the initial approximation. So basically in the question, they didn't tell us what is our initial approximation. So bila baca soalan tu, dia tak cakap start your iteration with what number. So since they didn't say, then that means we should try to choose any number between x equal to 1 and x equal to 2. Apa-apa number pun boleh, but normally we prefer to start with the middle number ataupun nombor yang tengah-tengah lah biasanya. So normally I start with 1 plus 2 over 2, which is 1.5. Okay, so x1 is equal to 1.5. Tak nak pakai 1.5, nak pakai 1.2, boleh? 1.3, kan? 1.4, that is also okay. 1.6, okay. 1.7, okay. 1.8 also okay. But do make sure never to use x equal to 1 and x equal to 2. Why never? Because you already substitute x equal to 1 and x equal to 2. And you already know that the value is definitely not equal to 0 and not even closer to 0. So don't use 1 and don't use 2 as well. Okay, so I already have the initial approximation, then we can use the formula. So xn plus 1 is equal to xn minus fxn over f prime xn. So the top one is fxn, the bottom one is f prime xn. Okay, so we're going to start with our initial value. So x1 is equal to 1.5. So the first iteration, x2. So x2 is 1.5 minus 2 sine 1.5 minus 1.5 over 2 cos 1.5 minus with 1. So substitute into the formula, use your calculator. The value for this is equal to 2.0765. And then you're going to substitute to find the second value, x3. So 2.0765 minus 2 sine 2.0765 minus 2.0765 over 2 cos 2.0765 minus 1. And then once you calculate this value, you're going to get 1.9105. So do make sure to be very consistent with your decimal places. So 4 decimal places, and continue until you see something that is similar. Okay, jom kita tengok sama tak lagi untuk X4. Okay, so I substitute with 1.9105 and I get 1.8956. And they are not equal yet. Not equal yet. So what do we need to do? Is we need to do another iteration. So go to x5. So x5 is 1.895. Okay, so basically for me, I'll continue again. Tapi kalau tak nak continue pun, terpulang lah. Normally for me, I prefer to make sure I have same decimal places. So yang ini 4 decimal places, ini pun 4 decimal places tapi tak sama bahagian belakang kan. So normally I'll continue until x6. So sampai sama ngam-ngam sebiji-sebiji semua baru saya stop. So yang ini I forgot to continue, so continue then. Okay, so once you have something that is similar, don't forget you must write down your conclusion. Therefore, the solution is x equal to 1.90. So if you go back to the question asks in 2 decimal places, 2 dp. So that is the reason why we are having something like 1.90. So in 2 decimal places. Okay, so the last question for today. So use the Newton-Raphson method to find an approximate value of the cube root of 15. Give your answer correct to 3 decimal places. So basically, we don't have our fx, right? So we need to know what is the value for fx. So we want to approximate the value for cube root of 15. So you can actually write down the x. Let x equal to the cube root of 15, and then you're gonna cube both sides. So cube on both sides. So we are going to get x cubed equal to 15. So bring everything to the left hand side. So we got x cubed minus 15 equal to 0. So one side of my equation is already equal to 0. Then that means my fx is equal to x cubed minus 15. So fx is equal to x cubed minus 15. Then what you can do next is that you're going to test the value so that we can find out our initial value. So yang ni yang saya kata biasanya kita pakai algebraic method ataupun change of sign method. If you want to, you can sketch, but it will be a bit hard for us to sketch. So normally we simply use something that is quite easy, which is the change of sign. Okay, so try to substitute with x equal to 2. You're going to see that the value is negative 7, which is less than 0, of course. Substitute with x equal to 3. So you're going to get something that is greater than 0. So one of them is less than 0, another one is greater than 0. We're going to say that we can see there must be a root between x equal to 2 and x equal to 3. There definitely need to be a root between x equal to 2 and x equal to 3. Okay, after that, what you need to do is that you need to find the derivative of your function f of x. So fx is equal to x cubed minus 15 What about f prime? So fx is equal to x cubed minus 15. F prime is actually 3x squared. Okay, so I do know fx, I do know f prime. The third step, I need to know what is my initial value. So I already test for x equal to 2 and x equal to 3. So my initial value is somewhere in between 2 and 3, of course. So what is the number between 2 and 3? So boleh tengok lah nak guna nombor apa pun tak apa. So I choose 2.5 because that is the easiest one. I'm adding 2 to 3. So 2 plus 3 over 2. So that is how I get 2.5. So once we know the initial approximation, you got to substitute into the formula. X2 is x1 minus fx1 over f prime x1. So substitute into the formula. So the value of this is 2.4667. Another iteration. So this is 2.4662. So do for x4. X4 we got another 2.4662. So we got a similar number over here, 4662, 4662. So these are the same. So this is actually our stopping criteria. So we know that we can stop once we get a similar number twice. So kita dapat nombor yang sama dua kali, benda yang sama, kita stop. Okay, so that means what is your conclusion? The cube root of 15 is 2.466. So, kalau kita tengok soalan tadi, dia minta 3 decimal places kan. So, sebab tu kita bagi 2.466. Okay, so one more thing that you should take note. Another one. I already remind you earlier, but I'm going to remind you again. Sebab dia nak put emphasize, so dia kena again. Okay, I remind you again. Okay, so since the answer, so this is basically the answer, right? So for the answer required 3 decimal places. So x2 up until x3, those are actually our working. So for the working, it should be at least 4 decimal places. So if this is 3, this is definitely 4. Or you can use 5 or 6 or 7 and so on. So kena atas lagi daripada answer. Kalau sama, penalty, kurang, penalty. So do make sure it should be more than what the answer required. So if the answer required 3 decimal places, always make sure you give a working that is more than 3 decimal places. Okay, so I think that's all for tonight. So we got another 2 exercise, so you can try to do them later on. Okay, so I'll see you guys this Tuesday. So we're gonna learn how to find the area under the curve using the trapezoidal rule. So we're gonna learn how to use the trapezoidal rule later on. Okay, so with that, I'll see you whenever I see you. Oh, by the way, Janelle invite. Good luck, miss. Good luck. Good luck untuk saya. Diorang ni senior. Senior dah habis. You guys ada lagi dekat channel saya. Sabar je lah. Okay, so I'll see you whenever I see you, everyone. So all the best. So I'll see you guys hari Selasa nanti. Bye. Selamat malam.